The wording in Section 338.10 of the 2005 National Electrical Code, or NEC, does not specify the material of the service entrance cable. The section says that branch circuits using service entrance cable as a wiring method are permitted only if certain conditions are met. Because the NEC doesn't state whether the cable must be copper or aluminum, we can infer that either material is acceptable. However, it's crucial to understand that the NEC is not exhaustive. It does not cover every possible situation or combination of materials. Therefore, the decision to use copper or aluminum service entrance cable for branch circuits should not be taken lightly. Firstly, consider the specific application. What is the purpose of the branch circuit? What loads will it serve? What are the environmental conditions? Secondly, consult with a qualified electrician or electrical engineer. They can assess the suitability of copper or aluminum for the intended use, considering factors like ampacity, voltage drop, and corrosion resistance. Thirdly, ensure compliance with all applicable codes and standards. The NEC provides a baseline for safe electrical installations, but local codes may impose additional requirements. Aluminum conductors offer advantages such as lower cost and lighter weight compared to copper. However, aluminum also has a higher resistance and is more susceptible to corrosion. Copper, on the other hand, has excellent conductivity and corrosion resistance but is more expensive and heavier. When using aluminum conductors, it is essential to use appropriately rated connectors and terminals. Aluminum connections can loosen over time due to thermal expansion and contraction, leading to increased resistance and potential overheating. Antioxidant compounds should also be applied to aluminum connections to prevent corrosion. The ampacity of service entrance cable must be sufficient to carry the load of the branch circuit. The NEC provides ampacity tables for different conductor sizes and insulation types. It is crucial to select a cable with an ampacity that meets or exceeds the calculated load. Voltage drop is another important consideration, especially for long branch circuit. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. The type of insulation used in the service entrance cable also affects its suitability for different applications. Some insulation types are rated for high temperatures or are more resistant to moisture and chemicals. The NEC specifies the types of insulation that are permitted for different wiring methods and environments. The installation of service entrance cable must also comply with the NEC. A cable must be properly supported and protected from physical damage. Ending radii must be observed to avoid damaging the cable. Grounding is another critical aspect of electrical safety. All electrical equipment must be properly grounded to provide a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. The NEC specifies the grounding requirements for different types of equipment and wiring methods. When using service entrance cable for branch circuits, it is important to ensure that the neutral conductor is properly sized. The neutral conductor carries the unbalanced current from the load and must be large enough to handle the anticipated current. The NEC provides guidance on sizing neutral conductors. Overcurrent protection is another essential safety feature. Branch circuits must be protected by circuit breakers or fuses that are sized to protect the conductors from overloads and short circuits. The NEC specifies the maximum overcurrent protection for different conductor sizes. The use of service entrance cable for branch circuits can be a cost-effective and convenient wiring method in some situations. However, it is important to carefully consider the specific application and ensure compliance with all applicable codes and standards. Consulting with a qualified electrician or electrical engineer is always recommended to ensure a safe and reliable electrical installation.